Hey guys, well, this week we're going to be taking just 2 sets of notes, one tonight and then one on Wednesday, and then I think that's how it works. No, one tonight, Monday, Thursday is when we're going to take the second one, and that will be it for this particular week. We'll have a few more, and then we'll be taking the test sometime in the subsequent week. All right, so let's go ahead and get started. This is lesson 5-4, and we're going to be talking about terminating and repeating decimals. So we did the decimal chapter at the very, very beginning of the year. I think we touched on this. Most of the time, our problems did end up terminating, meaning there was no remainder, though sometimes we did have to annex a 0 and continue dividing. But we did talk about, but we never practiced the repeating decimals. So first off, we're going to go back to a word we had talked about last chapter, and that's the word rational number. In fact, this was on your notebook quiz. It was also on your Chapter 2 test. Not everybody got this one right. This is any number that can be written as a fraction, or other name for fraction is a ratio. Now, for some reason, a lot of people, when the question was, what's a number that can be written as a fraction, a lot of you wrote ratio. But that's not a number, that's a comparison of two numbers. We're talking about a number that can become a ratio or a fraction. All right, so under this rational number category, we do have some decimals that actually are considered to be rational, okay? In order to be rational, we need to have decimals that terminate, and if somebody is terminated from their job, that means terminated from their job, that means that they are fired. If you have the movie The Terminator, he likes to end the lives of people. So that's what terminate means, is to end. That means there's no remainder. Or if we have decimals that repeat, and that means continue in a pattern. So, for example, you may have the same number just repeating forever and ever. You may have them repeat 1, 2, 1, 2, 1, 2. You may have it not repeat, and then beyond that number repeat. All sorts of different. So if you have either of these conditions, then these are considered rational. We did briefly mention the other day in class that there's another whole group of numbers outside of rational numbers that are irrational, meaning not rational. And I talked about how you have decimals like pi that never repeat and never terminate. They are not rational, they are irrational. Okay? So let's just talk about how we convert fractions to decimals. Just a reminder. Now, just to let you know, I'm probably going to be taking 2 pages, not so much because I have so much to say, but because it takes a little bit of space to do the work that I'm doing. So, convert fractions to decimals. Remember, this fraction bar right here tells us to divide. So we're going to take the top number, and I was still seeing mistakes like this on the Last test, 1 divided by 4 looks like this. And so just as a reminder, we're going to have the denominator is on the outside of the division symbol, and what goes underneath the division symbol is the numerator. So that's how we set that up, okay? And then just one more reminder about a terminating decimal. I got too many letters there. Terminating decimal. And a terminating decimal has no remainder. That means you divided everything, there's nothing left to bring down, and there's nothing left over, okay? All right, so we're going to do a couple of examples. I think, yeah, we should be able to fit them here. So the directions are going to say, write each as a decimal. And we're going to do a simple one, and then we'll do a little bit more complicated. So we have 4/5, and we're going to rewrite it as a division problem. So we're going to take 4 and divide it by 5. So first thing I know is 5 can't go into 4, so I'm going to put it into decimal point, bring it up, and that's going to allow me to say it doesn't go into 4 at all, so there's your 0, and it also allows me to add a 0 after the decimal point so that I could try to continue. So 5 goes into 48 times, and we kind of ignore that decimal point at this point. We subtract, and we get no remainder. So our answer is 4/5 is the same as 8/10. Okay? Second problem. We've got, and I'm going to read this two ways, the negative of 8/25. This is also the same thing as saying the opposite of 8/25. So if I can figure out what 8/25 is as a decimal, then I can take the opposite of the answer. So I'm going to highlight that negative sign or opposite sign, and we're going to go ahead and change this to a division problem. So we're going to have 8 divided by 25. Now here's the deal. If my original problem has an opposite out in front and just one of them, then that means my answer will also get it. So I'm also very keen, oops, that's kind of dark, isn't that? To put in the sign into my answer before I do my math, okay? Just so I don't forget about it. All right, so 25 can't go into 8, so I'm going to have to put in a decimal point, bring it up, and I'm just going to say 25 can't go into 8, so 0 up in the quotient. I can add a 0 in my dividend, and then I can continue to divide. So 25 goes into 83 times, which is 75, and when I subtract, I get 5 remainders. So I don't stop, I annex another 0, and I continue dividing. 25 goes into 50 twice, 25 times 2 is 50, and my decimal has terminated. So the answer to what negative 8/25 is, or the opposite of what 8/25 is, would be negative 32 hundredths, or the opposite of 32 hundredths. Okay, so just a little note here. A negative fraction, so that's when you have a sign out there, negative fraction will equal a negative decimal. Okay, so it just makes sense. So if your original number is negative, then it makes sense that even when you just change it to a different form, it's still going to be negative. So that one's terminating. We've practiced with that back in chapter 3. So let's talk about repeating. So we're going to go to the next slide. And for me, this was my second page. I know some of you are really teeny writers, and you can still fit it in. So let's talk about a repeating decimal. And a repeating decimal is a decimal with, digit or digits. So this is how this is written. You write the word digit, you put parentheses with an S inside, and that means it could be one digit or it could be more digits. So repeating decimal is a decimal with digits, digit or digits that repeat. That pretty much explains what that says. Now, what we use to determine or to demonstrate that we have a digit or set of digits that repeat, and by the way, if I have a set of digits, that means 1, 2, 1, 2. I would never write 0.33 repeating, because what's repeating is the 3. So I only write it once. So let's talk about bar notation, and I'm going to add that piece of information in there. So bar notation signifies, that means explains to the reader that a digit or a set, which is another way of saying group of digits, in a decimal repeat. Okay? So bar is just what it means. You're going to draw a line that covers what repeats. So we've got a couple things we're going to write down here. So first off, we're going to write the digit or the digit. Write the digit or digits, depending on the situation, whether it's just one digit or more than one digit that repeats. That repeat, write the digit or digits that repeat only, and here's the key thing, one time. Okay? And this makes me think about pineapples. Don't ask me why. So our special word for today is pineapple. Write that at the top of your notes. Pineapple. Try to spell it right. Pine-apple. Pineapple. Sounds like that silly video, huh? And then we're going to draw a bar over the digit or digits that repeat. Okay? So that's pretty much what the process is. Let's practice it. And believe me, we will spend some time in class doing this before you guys start on your practice. So we're going to write each fraction as a decimal. So notice it doesn't give you an indication whether you're going to get a terminating decimal or a repeating decimal, and the process doesn't change. It's just how you present the answer may have to change. So we've got just two examples to do. We're going to have 5/12, and we want to change that into a fraction. From a fraction to a decimal, sorry. So we have 5 divided by 12. So again, 12 can't go into 5, so I'm going to put in a decimal point, bring it up. 12 can't go into 5, so there goes the 0 into my quotient. Oh, that looks terrible. There we go. And then that allows me to put in a 0 in my dividend and now begin to divide. So 12 goes into 54 times, which is 48. And when I subtract, I get a difference of 2. So I'm going to keep bringing down one digit at a 0 at a time to continue dividing until I either terminate or repeat. So 12 goes into 20 only one time, which is 12. And when I subtract, I get a 0. Okay. So I'm going to bring down or I get an 8. Blah. So then I bring down a 0. And let's see, 12 can go into 86 times, which is 72. Ooh. Look what's happening here. 10 take away 2 is 8. And I'm right back where I was before, where 12 goes into 8 6 times, and I get 72. And when I subtract, I get 8. So I'm kind of in this little repeating rut. So what I do is I stop and I say, my answer is going to be 0.416. Okay. However, I need to put a bar just over the 6 to let my reader know that that 6 is going to repeat for on and on and on and on. And that we say this is 416 repeating? No, 4.416 repeating on the 6. Okay, so that's the answer to that one. Interesting. All right, here comes the ugly one. You thought that was ugly? You ain't seen nothing yet. First off, I'm going to give you a negative. I know. Mean. And then I'm going to have 5 divided by 7. And because I have this negative sign, I'm going to make sure I put the negative sign in my answer before I begin. So I know that 7 can't go into 5, so I put in a decimal point, bring it straight up into my quotient, indicate that 7 doesn't go into 5 at all, give me a 0 after the 5, and I start dividing. 7 goes into 7 times, which is 49. And when I subtract, I get a difference of 1. Annex another 0. And 7 goes into 10 once. And the difference is 3. Oh, still a remainder here. Annex another 0. 7 goes into 34 times, which is 28. Subtract. Get a difference of 2. Annex another 0. 7 goes into 20, just shy of 3 times twice, which is 4. And subtract, and I get a difference of 6. Oh my gosh, here we go again. 7 goes into 60, let's see, 8 times, which is 56. And we get a difference of 4. Annex another 0. Really important to keep things straight here. 7 goes into 45 times, which is 35, with a difference of 5. Annex another 0. And what you see is we're back to where we started, and we're going to get 7 goes into 50 7 times, and I'm just going to get 714,285, 714,285, and so on and so forth. So you can see this right here. And it's just going to keep going on. So my answer has a negative sign. In addition, it has a 7, a 1, a 4, a 2, an 8, and a 5, and a repeating bar that says all 6 of those digits are going to repeat. So I have to put the repeating bar over all of them. One thing to be cautious with the repeating bar, do not have it go over the decimal point, because your decimal point does not repeat. Now, I am going to tell you something special about this guy. Notice my divisor was a 7. So, dividing by 7 always, not sometimes, always results in a 6-digit repeating decimal. So why do I tell you this? If you divide by 7, or if you divide by a number that has a 7 in it, it still could happen. Just know that you have to go 6 rounds of division before you're going to see the repeat start. Okay? All right, we're going to get back in our brain with that division and the decimals. Well, see you later. Bye.